Hello world. In today's video, we are going to continue talking about Newton's universal gravitational law. And this will be our starting point for today. Please note that these three questions we are about to go through, these are normally multiple choice questions. Even the three graphs that we drew in the previous video, the graph of f versus r squared, f versus the reciprocal of r squared, and the third one, those are questions that we normally see in multiple choice questions. Okay, so it says the gravitational force between objects A and B, separated by a distance d between their centers, is F. What will the gravitational force be in terms of F if, number one, the mass of object B is doubled? So to figure that out, we need a formula. So the formula is F gravitational force equals to G m1 m2. So m1 here will be mass of object A, this will be mass of object B because those are the two objects we're talking about, divided by r squared. What is r? Remember they said that r in the previous video was the distance between the center of m1, the center of, let me say, object A and object B. So this time we were told that distance r is d, so we have d squared from the statement. So what we know from yesterday's lesson is if the mass of object B is doubled, to double something is to increase the quantity by 2, by a factor of 2. So if we double the mass of B, we are increasing it. So if we increase the mass of B, this product will increase. And as the product increases, F will also increase. But today's question is, by how much? By what factor will F be increased? So this is the original expression. I want to make my rubber a little bit smaller. Okay, there we go. I can just fix that up a little bit. Okay, so we have mass of A multiplied by mass of B. So this is the expression for the gravitational force that object A exerts on object B when they are separated by a distance d. What we are being told is the mass of B is doubled. So what that means is the new mass of object B will be 2 times the old mass. Okay, so it means you're going to have some new force, because we know that the product of the mass influences the force. So the new force will be G. The mass of B was the only thing that was changed. So it means G is still the same. The mass of object A is still the same. So now we have a new mass of B. I'm going to say M new divided by, because they said that the mass was the only one changed, they didn't mention anything else, it means that the distance between them remains the same. So if I come here, I have F new equals to G M A. I'm going to make the replacement. We said M new was twice the old mass of B. So we have 2M B divided by D squared. So what we are essentially doing is we want to write this new force in terms of the old one. So that we were told that we need to write the gravitational force in terms of F, and there's the expression of F. So what it means is that part, we need to find this expression into our new equation for the force, and we can do that by separating the numbers from the variables. So firstly, I'm going to write that up nicely. So it means I have 2 GMA divided by d squared. If I separate the numbers from the variables, I'm going to have 2 multiplied by GMA divided by d squared. But I have seen this expression before. We said that was equals to F. So therefore, the new force will be 2 multiplied by, I'm going to replace that whole thing with F because they're equal. So it means the new F is twice the old force. So what it means is, if you double the mass from this equation, when you double, sorry, if you double the mass of one of the objects, then the force will also double. It will also increase by a factor of 2. So in the description, when they tell you about the objects A and B separated by some distance and they tell you what the force is, what you should try to do is try to find an expression for that force, and then write a new equation for the new force, because clearly the force is going to change, and then write this force in terms of the old one. So the force will double. So let us try the second one. Please feel free to pause this video and try the second one for yourself before you move to the third one. Okay, so with the second one, it's still the same question. We have a gravitational force between objects A and B separated by a distance d. Between their centers is F. What will be the gravitational force in terms of F if the distance between the two planets is halved? Why did I say planets? This objects is halved. So in the first scenario, the old scenario, the original scenario we had object A with mass ma. That's the name we gave to the mass. And we were told that the gravitational force that they exert on each other is F. So F is equals to G ma b. We were told that the distance between their centers was d, so we have d squared. And then this time we are being told that the distance is halved. When you halve something, you divide it into 2 equal parts. So we are having a new distance here. The distance is d over 2 because the distance was halved. So think of it this way. So we were having this object A and object B. The distance between their centers was probably d, and then it was reduced. When you have something, you are actually reducing it. It was halved, now it is d over 2. And we know from the equation that when this distance decreases, then the gravitational force will be large. Okay, but let us see by what factor the gravitational force will increase. So the new force will be G. The mass wasn't changed. Mass of A, mass of B divided by the distance R now. R is equals to D over 2. So we have d over 2 all squared. So we can apply maths here. You have F nu equals to G M A M B divided by laws of exponents. You have d squared over 4. Okay. Or if you like, you can write this as it's all up to you. You could write it as 1 over 4 multiplied by d squared. So now to write this new force in terms of the old one, it means we need to separate the numbers from the variables. So F new will be equals to, remember that from maths, if there's nothing in front of the variables, then it means the number that is there, it's actually 1. So it means we have 1, then we have that division line divided by, and then there's that 1, another division line divided by 4. Then multiplied by, we have G M A M B divided by D squared. We have separated the numbers from the variables. Oh, I forgot my equality sign. So therefore, if you simplify this fraction on calculator, 1 divided by 1 over 4, the calculator will give you 4. So that will be 4 multiplied by, have we seen this before? Yes, we have seen it. That was actually F. So I'm going to replace it by F. So it means that the new force is 4 times the old force. So when you halve the distance, the force increases by a factor of 2. So halving the distance increases F by factor of 4. And I think with this problem, it's always the phrasing. So instead of saying the distance is halved, they could have said the distance between their centers is reduced by a factor of 2. And with the first one, they said doubled. When you double something, you increase it. So instead of saying doubled, they could have said increased by factor of 2. So if they increase by a certain factor, you multiply. If they decrease by that factor, then you divide by that number. I hope that is clear. So feel free to pause once more and try out number 3 for yourself. So with number 3, it's still the same original scenario. It says the mass of planet A is increased by a factor of 4, and the distance between the centers of the planets is decreased by a factor of 8. So what this part means is the new distance. Let me do this. The new distance between the centers is, because they're saying decrease by a factor of 8, it will be D divided by 8. They're saying that the mass of A, I don't know why I kept on saying planets there. I don't know why I'm having planets in my head. But we're being told that the mass of object A is increased by a factor of 4. So the new mass will be 4 times the old mass. When they say increased, you multiply, reduced or decreased, you divide. So the new mass will be 4 times the old mass. So we go back to our equation. F equals to G M A M B divided by D squared. This was before there was an increase in mass and a decrease in the distance. So now the 2 changes were made. I'm not going to rewrite the changes. So we're going to have a new force because the distance and the product of the masses affect the force. So G is still the same. Mass of A, it's new now. We have M new. Nothing was mentioned about the mass of B, so it means it wasn't changed. And we're being told that the distance reduced by a factor of 8. So we are having RSD divided by 8O squared. And now we can try to simplify. So the new force will be G multiplied by M new. We said that was 4 multiplied by MA multiplied by MB divided by, we can simplify the denominator. We have 1 over 64 multiplied by d squared. Okay, so I actually got d squared over 64, and then I separated that fraction. So now I'm going to separate the numbers from the variables. I'm going to bring this 4 in the front. So it means I have 4, and then there's that division line divided by, I have that 1, then I have the division line, and then I have 64. And then I have multiplied by GMAMB divided by d squared, and this is just simply F. So it means the new force will be equals to, I know sometimes the calculators make mistakes here. And when you press it on your calculator, please make sure that you press it appropriately. I'm going to work it out on the side in green pen. So we have 4 divided by 1 over 64. So remember, we can rewrite this as 4 and represent the division line with divide. Divide by 1 over 64. And if you want to change this into multiplication, multiplied by, then you need to invert the fraction. So you're going to have multiplied by 64 over 1. So that will, at the end of the day, just simply be 4 multiplied by 64. Let me grab my calculator. 4 multiplied by 64, that will be 256 multiplied by F. Okay, so that's it on those factors. I want us to take a problem and try to work on it. But before we do it, I need to bring it to your attention that when you are busy applying this formula, the universal gravitational law in mathematical form, please take note of the meaning of R. R is the distance between the center of MA and the center of MB, or the center of object A and the center of object B, because the meaning of this R gives us different cases to work with. So my advice is, when you solve the problems, number 1, draw a sketch. Draw a sketch. Most importantly, indicate R on the sketch. Indicate R. Number 3, write your data so that you don't make any mistakes. So the first example says the 2 moons of Mars, Phobos and Deimos, I hope I'm pronouncing them correctly. The mass of Phobos is given, the radius of Phobos was given, the distance between the center of Mars, the planet, and Phobos is that much. So it's the distance from the centers. The mass of Mars was given as that much. Calculate the gravitational force of Mars on Phobos. And I like the fact that there's a lot of information that was given there. Number 1, start with a sketch. We are given Phobos because we want to find the force between Phobos and Mars. That will be Phobos, and let us say that will be Mars. So we know the mass of Phobos. We were told that that mass is 1,1 times 10 to the power of 16 kilogram. And the mass of Mars, I'm going to call this mm, was given as 6,4 times 10 to the power of 23 kilograms. And for us to apply the universal gravitational law, the distance in the law is the distance between the centers of these objects, the center of Phobos and the center of Mars. The distance between their centers, we are being told that is 9,377 kilometers. Remember, in physical sciences, our units for distance are meters. So we need to convert. When I do my conversions, just a side trick. So I use I think it's a Sotho name. I write it in capital letters. Then the next thing that I do is I remove all the vowels. Your vowels are your R, A, E, O, O's. So vowels gone, 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 gone. Now I am left with K, M, G, T, S. And just for fun, I'm just going to remove the last letter. Because I wrote these in capital letters, these are going to be my conversions for larger scales. So you have your K, M, G, T. These conversions, they work anywhere, whether in mechanics, electrostatics, or whatever topic you're dealing with. So if I see a K in front of SI units, I am going to replace it with times 10 to the power of something, times 10 to the power of something, times 10 to the power of something, times 10 to the power of something. So what is nice about this arrangement is that these powers, they differ with multiples of 6. So this will be 3, 6, 9, 12. K is for kilo, this is mega, this is giga, and then this is tera. Where you see tera, it could be terahertz. You replace the capital T with times 10 to the power of 12. So that is the conversion for larger scales. So it means that distance there is actually 9,377 times 10 to the power of 3 meters. So on this video, I'm just going to quickly go through the conversion for smaller scales, just in case you need it. Okay, for smaller scales, because it's smaller scales, I use small letters. So I use is it a mnemonic? Something like that. I use man. So you have man. So where I see small m, I replace it with times 10 to the power of something. I replace it with times 10 to the power of something, times 10 to the power of something. And because these are smaller scales, for me to get a smaller answer at the end, I need to raise these tens to the power of negative numbers. The most lovely thing about this order is that the powers, once more, they differ with multiples of 3. So that will be -3, -6, -9, -12. Small m is for milli, this is for micro, this is for nano, this is for pico. These conversions, they are normally used in electrostatics. Yeah, mostly in electrostatics. Yeah, but maybe they might appear in mechanics. I don't know. Okay, so that is how you do your conversions. Then it would mean when you have something like, let me write this in yellow. Let's say you have 4 nanometers. Where you see the nano, you replace the nano with times 10 to the power of -9. And that distance would be converted to meters. Okay, I hope it's clear on those conversions. That's how you can memorize them, because I know they're there in textbooks, but it just becomes a little bit difficult to memorize them. Okay, so remember, one thing worth mentioning, this small r is for distance. I know in mathematics it's used for radius. No, for us, that is the distance. So it turns out that we don't actually need the radius of phobos. One piece of information that is just a distraction. Okay, so now we have drawn our sketch, indicated R, we can perform our calculations. F is equals to, let me write it here. We have F equals to G m1, so that will be the mass of phobos, the mass of Mars, divided by the square of the distance between their centers, and then you can sub in. Remember, G, it's always given on the data sheet, and then the mass of phobos that is given times 10 to the power of 16, and then the mass of Mars, that is 6,4 times 10 to the power of 23. Always make sure that your R is squared, because that's one of the mistakes I see when I mark scripts. To the power of 3 all squared. Therefore, the gravitational force, remember that the force will be in units of newtons. multiplied by, I'm just using my calculator over here, 16 multiplied by, you can verify the answer as well. Not really a fan of a calculator, but I gotta do what I've gotta do. All squared. Okay, my calculator tells me, that's a very large value. That's how I know that it can't be the correct answer. Okay, let's see. 6,67 times 10 to the power minus 11. Okay, let me give this answer a benefit of doubt. My calculator says the answer is 5,34 times 10 to the power of 15 Newton. I'm not the best person with pressing calculators, so you can confirm that one for me. In physical sciences, most of the answers, they go to formula, the bulk go into substitution, and finally the final answer with correct unit. Okay, so in the next video, we are gonna look at another problem, because you're not always gonna be given the mass, the distance. Sometimes they might ask you to calculate the distance. So in tomorrow's video or in the next video, we're just gonna look at more problems and exam type questions. That's it from me for today. Thank you.